To civil engineering professionals, municipal planners, and anyone keen on infrastructure innovation, subscribing to AXA Engineers, Civil Engineering Global Solutions offers pioneering insights. Is it possible to construct a road that meets all regulatory and durability standards while operating on an exceptionally constricted budget? This is a primary challenge in civil engineering today. Until now, most firms accept those trade-offs. AXA Engineers' method breaks that rule. With over 15 years of experience, AXA Engineers proves smarter engineering trumps budget constraints. In this behind-the-scenes case study, viewers will discover how AXA Engineers uses Civil 3D, Dynamo, and more to deliver roads that exceed regulatory standards on a lean budget. The foundation for these results is established long before construction begins. Digital optimization, the pre-construction advantage. In the world of modern infrastructure, the greatest opportunity for cost and risk control lies in the pre-construction phase when every decision exists as data. This is where AXA Engineers' methodology, centered on digital optimization, sets itself apart. The main challenge is translating complex project requirements into a design that is both computationally verified and cost-effective. To illustrate, consider the Mitchell Mill development project in North Carolina. Here, steep terrain and sensitive watershed areas were navigated, all under a restrictive budget that left no margin for error. Traditionally, road design teams work in isolated stages: concept, drainage, utilities leading to costly revisions. In such workflows, an initial concept is developed and then passed sequentially to other teams, creating information silos. When a late-stage optimization is discovered, it often triggers a chain of expensive redesigns, since foundational geometry has already been approved. This fragmented process overlooks holistic optimization and can result in unexpected change orders once construction begins. Streamlined workflow. From concept to digital. Twin AXA Engineers' approach fundamentally reorganizes this process by leveraging Autodesk InfraWorks at the outset. For the Mitchell Mill project, multiple road alignments were rapidly generated within InfraWorks' 3D environment. Stakeholders, including municipal planners and environmental consultants, could instantly visualize each alignment in context, seeing real-time impacts on property boundaries, sightlines, and protected stream buffers. This immediate feedback compressed what would have been weeks of preliminary meetings into a few focused sessions, allowing consensus to be reached on the optimal alignment far more efficiently. Once the preferred route was selected, the model transitioned into Autodesk Civil 3D. Here, a comprehensive 3D digital twin was developed far more than a set of drawings. Every element within the model, from pavement layers to drainage structures, carried embedded engineering data. For example, a curb in the model is an object with defined material, dimensions, and its relationship to the road profile and subgrade. This level of detail is essential for downstream analysis and coordination. Enhanced efficiency with automation and clash. Detection efficiency gains accelerated with the integration of Dynamo scripting. Dynamo, a visual programming tool linked directly to Civil 3D, automates repetitive and complex design tasks. For Mitchell Mill, Dynamo scripts were used to automate corridor modeling and earthwork balancing processes that would otherwise require hundreds of manual iterations. Instead of an engineer testing a handful of profile options, these scripts ran thousands of iterations, algorithmically adjusting grades, cross slopes, and ditch profiles to minimize soil displacement. This approach delivered a double-digit reduction in earthwork volume compared to manual methods, directly reducing hauling and material costs. The ability to test many scenarios in a fraction of the time not only cut costs, but also improved the design's environmental footprint. Corridor modeling also benefits from Autodesk vehicle tracking, integrated where geometric constraints require precise vehicle path analysis. This tool's role will be covered in detail later in the workflow. Coordination and risk reduction are further enhanced by Civil 3D's clash detection capabilities. In the Mitchell Mill project, a digital clash check identified a conflict between a proposed 36-inch storm drain and a high-pressure gas main. Adjusting the drain's alignment and elevation in the model resolved the issue instantly, saving days of potential field delays and avoiding unbudgeted rework. The final product of this digital process is an optimized 3D model, refined through computational precision and validated for constructability and cost-effectiveness. This digital diligence is the first proof point. Significant savings and risk mitigation are engineered through advanced technology, not by cutting corners. But a flawless digital model is only a theoretical success. The next challenge is ensuring that this precision carries through to the physical construction, where every detail must withstand the realities of the field. From digital precision to physical construction. Translating digital precision into a finished roadway requires rigorous on-site quality assurance at every stage. This process centers on connecting the design office and the field in real time. Using Autodesk Construction Cloud, field crews access the live civil 3D model on tablets, ensuring every cut, fill, and pipeline matches the design. With this setup, surveyors, equipment operators, and project managers all reference the same up-to-date information, eliminating discrepancies that can arise from outdated paper plans or miscommunication. When questions or changes occur, updates are pushed through the platform and immediately visible to everyone, preventing costly mistakes and ensuring that physical work mirrors digital intent. Before construction begins, the project team verifies that the digital design will satisfy regulatory requirements, particularly for stormwater management. Using Storm and Sanitary Analysis, SSA, engineers simulate extreme weather events such as a 100-year rainfall to confirm that drainage systems will handle runoff without causing localized flooding or erosion. SSA's modeling allows the team to test the placement and capacity of culverts, ditches, and retention basins against municipal codes and environmental standards, providing confidence that the infrastructure will perform reliably under real conditions. Once earthwork begins, attention shifts to verifying material quality and construction practices. At each stage, AXA Engineers enforces a protocol of soil compaction testing and asphalt quality analysis. Soil samples are collected and compacted according to standardized procedures, such as the Proctor test, to determine if the in-place density meets design specifications. Achieving proper compaction is critical for ensuring a stable foundation, preventing future settlement, and supporting the long-term durability of the pavement. As paving progresses, asphalt core samples are extracted from the roadway and sent for laboratory analysis. These tests evaluate key properties, including binder content, aggregate gradation, and air voids, confirming that the asphalt mix possesses the necessary resistance to rutting, cracking, and premature aging. All test results, soil compaction data, and asphalt core analyses are logged directly into Autodesk Construction Cloud. This creates a transparent, time-stamped quality record, tied to specific locations within the project. The digital log not only provides evidence that every layer meets or exceeds engineering standards, but also enables traceability for future maintenance or regulatory reviews. This step-by-step documentation builds a verifiable chain of quality from subgrade preparation through final surfacing, ensuring that the completed road is backed by both digital and physical proof. This systematic approach earned praise from Palma Land Planning's president Casey Palma, who notes AXA Engineers teams consistently strive to exceed expectations. Such feedback underscores the value of a process that integrates digital coordination with on-site validation, assuring clients and regulators that each project not only meets, but often surpasses required standards for safety and durability. Through this fusion of real-time digital coordination and rigorous material verification, AXA Engineers establishes a process where efficiency and quality reinforce each other, not compete. The result is a road that performs as designed on budget, within schedule, and with a documented record of compliance. Next, this demonstrates how these digital and physical checks translate into long-term performance on real roads. AXA Engineers' approach demonstrates that the old trade-off between project cost, quality, and speed no longer applies. This is not a single tactic, but an integrated system where technology enhances engineering expertise at every stage. By embedding quality assurance into both digital modeling and on-site verification, cost-effectiveness becomes the result of a transparent and efficient process, rather than a compromise. If you're a civil engineering professional seeking to slash costs without risking quality, subscribe and hit the bell to explore more behind-the-scenes innovations. AXA Engineers, recognized by Autodesk and APAC Entrepreneur magazine, invites you to redefine your cost-quality paradigm. Adopt a technology-driven workflow, and you'll see cost-effectiveness as the outcome of precision, not compromise.